Thanks for joining us at Tech Freeze. In this video, a long-awaited project is begun. A tunnel is being dug from a bunker, built 11 years ago, to the creator's house. The effort is inspired by the movie The Great Escape, and the tunnel is named Dave, as a personal reference, echoing the original escape tunnels, Tom, Dick, and Harry. To reinforce the exposed soil, steel sheet panels are installed around the perimeter of the dug sections, providing structural support and creating a finished surface. Stainless steel pop rivets are used to secure the soil during tunnel construction.
Let's go in.
The boring machine is built with swinging arms to support its weight and prevent twisting. It is designed to pivot up, down, and side to side, allowing for easier handling in confined spaces. The tunnel boring machine is assembled from various repurposed components, including a treadmill that functions as a conveyor belt. Instead of buying expensive machinery, the creator relies on DIY engineering, welding together swinging arms and using salvaged parts to build a functional rig. The arms are cleverly designed to pivot in all directions and bear the heavy weight of the boring head, allowing for better control and stability inside the confined tunnel space. With Tunnel Dave, the creator not only pays tribute to the great escape tunnels of World War II, but also brings the spirit of those daring escapes into a modern DIY context, blending history with inventive home engineering. Flooding becomes an ongoing issue. Water is visibly pooling at the bottom of the tunnel, with deeper accumulation toward the far end.
The water's been flooding in, and look at that. Add a bit of cement, we'd have perfect concrete, wouldn't we? This pump's working really well now. Look at this.
As the digging goes deeper, more and more water starts seeping in. The pump's doing its job, but it's working harder the further the process goes. These metal sheets act as a temporary retaining structure, preventing soil collapse and maintaining tunnel stability during construction. The excavation method has shifted from using a tunnel boring machine to a more manual drilling tool, likely for greater precision or due to space constraints. It's a bit more labor-intensive, but offers more control in tighter sections.
I thought digging sideways was hard. Digging upwards is 10 times harder. I thought gravity just helped you, but you're having to ram the drill upwards and put so much weight upwards. Anyway, I've got a bit of a dome shape on it now, so it will naturally hold itself. It'll be a lot safer, hopefully. I can just keep the middle higher than the sides, and then I think we'll be all right then.
Shaping the tunnel ceiling into a dome is a common technique in underground excavation, especially in soft or unstable ground. The arched profile redirects earth pressures toward the walls, where they're more easily supported, reducing the risk of collapse or shear failure.
We were filling the buckets, but we're running out of time fast, so It was just basically pull as much down as possible and keep digging. See the hole there? So what I came up with the idea was, because I hadn't had time to make a ladder, is we used the shovel as a bit of a ladder. You have to stand on there like this, shimmy your way up, get the other leg on there. We have a good look round, check it's safe. So get your arms up like that, wobble yourself up, just pressing on the sides, and that's it. I'm about up to freedom.
Although the current excavation is being done from outside rather than from inside the tunnel, it hasn't made the job any easier. In fact, digging from above comes with its own challenges, especially when the ground is hard and compacted. The tunnel continues to be reinforced using metal sheet panels, just as in previous sections. These sheets are installed along the walls of the excavated area to maintain the overall shape of the tunnel.
Look at that. Pull the catch.
An electric tunnel cart has been assembled and mounted to run on tracks. It allows for the efficient transport of loads, streamlining operations, and minimizing manual labor. As the tunnel extends further, the volume of excavated soil increases significantly, making it progressively more difficult to manage. As part of reinforcing and improving the tunnel entrance, a support strut is mounted.
Bought 2 of these thinking we needed 2, but it does come up pretty well. What do you think? Parts I folded earlier. That's the sump in, look. So now after this, there's 2 sumps at the lowest point of the tunnels. They'll always have these pumps running in them. So we start off where we left off on the last one. Finish off the sump section with a new pump in, obviously fitting the railway track supports on here.
Bunker construction begins with thorough site preparation, including surveying and marking the area according to the plans. Excavation is carried out with an excavator to achieve the precise depth and dimensions required for the foundation and underground structure. A gas bottle is mounted onto a hoverboard tray, transforming it into a mobile impact tool. It is then forcefully pushed forward to strike the tunnel wall from inside the bunker. After the initial breakthrough is completed, excavation work continues on the bunker foundation. This involves digging to the required depth and dimensions to accommodate the structural base of the bunker. The surface is compacted to eliminate air pockets and increase its load-bearing capacity, ensuring a stable and level base. To reinforce the bunker foundation, rebar is cut, bent, and tied into a grid that will be embedded in the concrete. This reinforcement helps the concrete withstand external forces, such as ground pressure and shifting loads. The concrete is carefully distributed to ensure even coverage and proper bonding with the steel reinforcement. It is then leveled and smoothed and left to cure over time, allowing it to harden and gain strength.
Oh, it's like down the tunnel. What's going on?
It is now time to prepare the vertical reinforcement for the bunker's concrete walls. This reinforcement is crucial for increasing tensile strength, enabling the walls to withstand external pressures and resist cracking. The reinforcement at the tunnel entrance is cut back to clear the entryway. This removal ensures unobstructed access while preserving the structural integrity of the surrounding reinforced sections. Moldings are installed to shape and support the concrete walls during pouring, ensuring the concrete sets to the desired shape and dimensions while providing stability and a smooth finish. Concrete is poured into the installed wall moldings, maintaining a consistent flow rate to prevent interruptions that could create cold joints or weak spots. During pouring, the concrete is vibrated to help it settle and compact properly within the mold, avoiding air pockets. Proper curing helps prevent cracking and ensures the bunker walls meet the necessary durability standards to withstand environmental pressures. Gravel is poured between the exterior of the concrete walls and the surrounding soil to create a drainage bed. The area is then backfilled with the previously excavated soil. A rebar mesh is laid across the entire surface, completing the site preparation for the subfloor concrete pour. A dry mix is laid into the footing trench to absorb residual moisture and stabilize the base before wet concrete is added. With the help of an assistant operating the digger, the concrete is distributed more efficiently around the site. Heavy rain begins during the process, complicating the pour. However, the wet conditions unintentionally aid in leveling by keeping the mix fluid and self-leveling.
But when we take the wooden shuttering we put out on the outside, that starts making the cavity drain. It's going to have a brick wall built on the edge of that, 90mm kingspan on the walls, plus this waterproofing. So I think we'll do the waterproofing next, shall we? These are my reclaimed bricks I bought. They all look pretty nice. They match colour-wise pretty exactly to what I've got on the house, but they are a little bit taller, but that won't matter for the downstairs layer. This is the waterproofing stuff. That goes against the wall, comes out 8mm. The water should always keep against the wall apparently, into the tray at the bottom, so obviously this is a tuck in. This is a jetting hole here, so effectively that's going to be in the brickwork like that.
A tunnel arch template is fabricated using welded metal sheets.
That's the template there for the tunnel arch, so effectively these bricks are going to go round. Find one with a nice face, eh? But they go round like that.
A protective tent top is constructed over the work site to shield ongoing operations from weather changes.
They're solid. They are really, really heavy. Just imagine trying to do all this lot in the pouring rain. It's chucking it down out there. All the water would be running down here. It'd be horrendous. Last Friday, building this tent was the best thing I've done lately. Looks like a proper archway, doesn't it? Bit of work here. Let me know in the comments. We've done the right thing spending all this time cutting this. I think I have. I think it's going to make a lot better job. So these top bricks are in place. You see my guides underneath, can't you? So they've got, that shows you the brick and then the mortar. The mortar has to match all the stuff we've got here. The reason we're on that thickness of 11.6 mil is so we hit the right height at the top.
A steel ladder is constructed using welding techniques to withstand heavy use and environmental stress, ensuring it remains reliable and safe over time.
So I can do these up now. Don't know how long you're going to leave them, but that is tight.
The ladder steps are precast with concrete, providing a solid surface for footing.
Filling the bead at the edge with some mortar before we slide it in. Hey, you've done it, look.
The creator incorporates a 1944 Ford GPW Willys Jeep, formerly used by the British Army, into the build as a symbolic gesture to create a memorable moment. It turns out, the tunnel ceiling is too low to connect properly to the new bunker. To fix it, part of the existing tunnel must be dismantled to allow for proper alignment and access. The process has to be done without any structural support underneath, so each tunnel segment is carefully removed to avoid collapse. Every step is taken with extreme caution. The realignment is considered essential to ensure a proper and stable connection between the tunnel and the new bunker.
The problem with this ground, it is just sand and stone. So the water flows straight through it. It will drain and get away all right. Lift this onto the cart like that. Pretty grim. And get down the other end, see in a bit. Still one of the best inventions I've ever made, and the simplest. How simple is that? Just leave the hoverboard you drive forward and back. For other people that don't know what they're doing.
A ratchet strap and some timber blocks are finally used to lift the section and bring it into proper alignment, ensuring it is leveled accurately without causing any damage. The process then continues with drilling to further excavate the area.
The last 2 foot, we can do this.
This step is carried out carefully to break through compacted soil and create the necessary space.
Quite excited that we're about there now.
The sump tank was designed to manage both internal and external water drainage.
Digger John helped me yesterday and we got this dug out here, and obviously that's going to be for the sump pump there.
Additional digging is required to adjust the depth and alignment. A specific tunnel segment had been prefabricated with a cutout to accommodate the sump tank.
Well, I've gone deep enough for that. With pea gravel.
The sump cavity was filled with pea gravel to promote effective drainage.
Then I assemble the last section together and get it slid down the gap. And then I fitted the final tunnel stiffening bars in, just again to follow the correct path. So I try and use blocks of wood and knock them across and then put the screws in. It seems to work quite well. The only problem is I do all this and then remember I need to put this panel in, so I have to take them all back out again, but never mind. The tunnel, you can see the correction we did at this other end where we went uphill at the end. I think this is absolutely awesome, but at the end of the video we're going to show what the other scanner and this scanner and Ian's going to do some tricks.
Necessary cutouts are made, and holes are drilled around the perimeter of the steel sheet that will be used to fabricate the tunnel door. The letters T and D, representing Tunnel Dave, are also cut from the same sheet and mounted onto the door as a personalized touch. A wheel was fitted to operate the door mechanism, with a chain routed through a gear system to control the latch. On one side, the latch mechanism engages with the door catch, while on the opposite side, hinges are used instead. Both sides are connected by a shared chain loop.
Fit.
A new cog is cut and then installed on the opposite side of the gear axis, allowing the gears to rotate in complementary directions when linked by the chain. This setup enables synchronized door movement, allowing the system to operate efficiently.
Forever. I'll put my new wheel on, but that's it. The bottom goes down. Can we get in there?
The door combines a professional finish with creative DIY craftsmanship. Next, a functioning log burner is built to swing aside, revealing a hidden entrance behind it. Due to its weight, around 100 kilos, it will be mounted on heavy-duty hinges anchored to a nearby post. To ensure precision, the metal plates are laser cut, allowing for clean edges and accurate dimensions. For added strength and durability, the components are then welded together, creating a solid structure. High-quality steel plates are selected for the log burner door too. Decorative details are added, giving the piece a handcrafted and visually striking appearance. A section of the door is cut to house a pane of heat-resistant glass, which allows the fire to be viewed safely while containing heat and flames. The rectangular steel sheet is cut, rolled, and welded to form a seamless, airtight cylindrical pipe. It is then firmly welded to the burner body to prevent leaks and maintain structural integrity under high heat. An L-shaped steel plate is prepared to serve as the door for the hidden entrance. This plate is designed to support the log burner, providing a stable base while also protecting the wall and floor behind it from the burner's intense heat. Heavy-duty hinges are attached to allow the plate to swing smoothly aside.
This is live, straight off the machine.
The chimney is designed to rotate in unison with the burner as the secret door opens. Specially angled pipe sections are cut and welded together to enable smooth rotation. To maintain functionality while preserving the hidden entrance, this solution ensures that the chimney spins smoothly without compromising its sealed connection to the burner. The pipe assembly is aligned with the chimney to safely vent smoke outside.
Secret latch. But if I pull the chimney and push it round like that, now we're slightly... Shut it again. Fire's warmed up. She's working a treat. To move, you have to just tap it across. It seems to be sticking like that. Now it's hot. You see that? Also, we need a way of opening it up in this end as well, because this, at the moment, that's mega hot. I can just about touch this bracket all right. I've cut the tracks here, obviously. You probably noticed no tracks anymore. The new plan for the tunnel car is to make it so it runs on rails and on rubber wheels, right? So we don't need tracks at either end.
The main goal now is to build a remote-controlled tunnel cart that can move forward or backward on command. It also needs built-in speed limits to ensure it's safe to ride in, reducing the risk of accidents. The chassis is cut from 3 mm galvanized steel. Wheels and components are salvaged from other parts. Gears made from 2 mm steel are positioned with magnets, then welded and bolted in place. A drive cog is welded to a shaft for the drivetrain. A double wheel hub is assembled, and the shaft is machined on a lathe to complete the axle. A speed controller is installed onto the tunnel cart. This particular model is fully programmable, allowing adjustments to top speed, acceleration, braking force, and regenerative braking.
Turn it on. Stop. Come back to me. Seems to be handling the bend all right. So we can get rid of these rails now. Don't worry, I have no idea what I'm doing. After everything I've done so far, I'm just having a go. That's what I do. There's probably someone out there tiring, laughing at what I'm doing right now, right? Thinking he knows nothing, and that is because I don't. But never be scared to have a go at stuff. That's my motto. Obviously, when I read the comments, I realise where I went wrong on the ad. And I'm quite glad because I'm already using way more tile adhesives. I know I should have started at the back corner of the room, not this edge here, but the reasoning behind...
The final adjustments are carried out to complete this incredible project.
Same stuff I used to fasten the tiles down on the floor, put it at the back, squidged it in by pushing it in. Up, round, in. Floor looks now, needs a bit more of a clean, but as you can see it's looking pretty good. It's all done in the cupboard, it's all done up to the tunnel. Want to get this finished, but we've run out of time on this video. But anyway, toilets work. A quick look at the step of how she's looking. I think that looks absolutely spot on. So we've got a bit of a time. That just pushes up. It does expand
Like I say, this isn't necessarily the stuff I want to use. I wanted to use the galvanised stuff, but I just wanted to get this thing working for now, somehow.
A ventilation system is assembled to improve indoor air circulation. Ventilation is set up, but the space is still not cooled sufficiently, especially during gatherings. Therefore, cold air is planned to be added to improve cooling. The Jeep's front panel is being worked on, with the cold air intake planned for installation. The grille of a Jeep is made from 6 mm thick metal, because the flared and rolled edges found on a real Jeep require specialized press tools to replicate.
She is mounted. That is solid.
Black to red.
So that's the best I can do. I've put some bits of paper over the lights. It does look cool, doesn't it? Right, I've run out of time in this episode. I wanted to get it all finished and working, but it'll be another 2 weeks before this actually comes out then. Obviously, if you like this video, you want to see more, don't forget to subscribe. And other thing, if you are subscribed, click the notification button, because I never told anyone to do that. And I've noticed if you don't do that, you don't get told about the videos. So if you just click on the little bell notification thing, if you want to watch more of it. And I will see you in 2 weeks when we'll actually finish this job off, which I've been trying to do. Sorry it's been took so long. Part 3, we'll have it finished. We'll have cold air blowing in here. See you all then. Bye-bye.